All right, we are going to go over 7.7. That's called double identity, and it's called solidifying understanding. And so we're actually going to do this jumpstart together because this is what you need in order to do kind of like a proof that we're going to come up with for one of the identities. So it says find an expression that will give you the length of the other two sides of the right triangle using capital N and beta. So they want you to find this, which I will label as Y. Usually, Miss Johnson labels your vertical side Y and your horizontal side X. And they're just asking, can you give me a relationship between Y and N and B and X and N and B? Okay. So you're thinking like, okay, Miss Johnson, I could give you the trig. My two tools are Pythagorean theorem and trig. And I won't use the Pythagorean theorem because they wanted your answers to have N and B in it. So then you're like, oh, I could use trig. And very good. So then we're looking at SOHCAHTOA. Okay, so I'm going to start with sine of beta. Beta is just the Greek letter B. That's all. So sine of beta equals to opposite over hypotenuse, which would be y over n. Okay. But then pay attention. They said find an expression that will give the length of the other two sides. So they want you to solve for y. So they want you to solve for y. And you're like, oh, no problem, Miss Johnson. I'll just multiply both sides by n. And then I'm done. Very good. So then y equals sine beta times n. Okay, so it's n sine beta. So this is my first answer for y. So then can you find one for x? So go ahead and pause the video. Find it for x. Very good. And then check back with me and see if you got it right. This will help you in our little proof that we're going to do in a second. All right, now that you're back, you're like, oh, Ms. Johnson, it has to be cosine because that's the adjacent side. So we say cosine of beta equals to x over n. And again, they want you to solve for x. So you're going to multiply both sides by n. And so your answer is going to be n cosine beta. Ooh, what is that? Sorry, my Apple Pen went crazy. Or it was me. And then there's your answer. So n cosine beta equals x. So this is not anything new to you. They're just having you practice using no numbers, all variables, just so you can get used to this. So today you'll be able to derive trig identities for the sum or difference of two angles. It looks like this. This is what a sum looks like. So we're adding within the angle, and you're like, Ms. Johnson, that's weird. Yeah. So we're gonna find that because that's actually gonna be really helpful for later, and you'll see why. So it says, why might some people think that sine alpha plus beta equals to sine alpha plus sine beta? And what evidence might I prove that this statement is incorrect? So this is not right? This is not an identity. Sine alpha plus beta is not equal to sine alpha plus sine beta. And then it says, is there an expression that is equivalent to sine alpha plus beta? So that's what we're going to work on today. So it says, sometimes it is useful to be able to find the sine and cosine of an angle that is the sum of two consecutive angles of rotation in the upcoming diagram. Point P has been rotated alpha radians counterclockwise on the unit circle to point P, and then point P has been rotated an additional beta radians counterclockwise to point R. In this task, you will examine how the sine cosine of alpha, angle alpha and beta, and the sum of those two angles are related. So I'm going to do this. It says, why do you think this statement is not true? Why do you even think people think that this is true? Like, look at that. And some people think, oh, it kind of looks like the distributive property, Ms. Johnson. And I'm like, oh, yes, the distributive property. 4 parentheses x plus 2 equals to 4x plus 8, right? And you distribute that 4 and you multiply that. That is a true statement. Distributive property works. Ms. Johnson, how come this distributive property doesn't work for sine alpha plus beta? Because in this case, the thing you're distributing is a number. Sine is not a number, it's a function. It's an action. You're doing something to it. It's actually asking you what is the ratio of opposite to adjacent. So you can't do that individually because it doesn't actually work, and you'll see why in a second. Okay. So it says examine the diagram a figure OACD. It's a rectangle. Does everybody see OACD? They're saying that's a rectangle. This is a really confusing diagram. I'm going to break up all of these pieces in a second. That way you can see it. I will say that one of the things that your brain is supposed to get trained on is looking at this and seeing how all the parts kind of build it up. So, like, I don't know, if you were a really good Lego builder, if I showed you like a Lego car and you could be like, and you would look at it and you're like, oh, okay, I get it. I know how to build this. So, another thing that you could be good at is like if you're good at baking or cooking and I let you taste a really good, I don't know, cookie and you would eat it and you'd be like, oh, ooh, I taste, I don't know, a little bit of brown sugar in here, a little bit of vanilla. Ooh, you did something different. What is that? And then you figure out, oh, she put toffee in it or something like that. Right. So, your job as a mathematician is to be able to look at a diagram like this and be able to separate it out and put it back together at the same time. Okay. So, I'm going to give you some hints along the way just so that you can be helped with this. You should not be able to come up with this on your own, but I do want to show you this because it's doable. It's just right now it feels like it's impossible. Okay. So what we're going to try to do is we're going to try to find what sine of alpha plus beta actually is equal to. Okay. And if you look at where alpha plus beta is this angle here. Okay. And the confusing part is the only information that they kind of gave me is that the fact that this is a unit circle and this hypotenuse right here is 1. Now, this hypotenuse from this right triangle OBA, his hypotenuse is not 1 because 1 goes for all the way from O to Q. Okay, so your radius is going to be this. Oops, I'm not in highlighter mode. Sorry. Your radius goes from center to circle, center to circle. Do you see how that goes past that right triangle of OAB? Yeah, so we're not going to be using that one. So the very first triangle that I'm going to look at is the triangle that we know the most about. Whenever you start doing these kinds of things, we're going to always start with a triangle that we know most about. So we're going to be looking at triangle OBR. Okay, OBR. And because I really want you guys to learn this, I'm going to redraw him over here and I'm going to write, I'm going to constantly go back and forth and refer back to him. So let me just put him over here because I don't want it to be very, this was this is OBR. We know this is a right angle and we know this is 1. And I said, hey, I want you to find me the length of this length here, RB. I'm going to call him, I don't know, S. I'm going to run out of letters later on, so that's why I'm using S. And I want you to find me T here. So go ahead and do that and then come back to me when you're done. This is the same thing that you just did in the jumpstart, so you guys should be okay. Oh, I forgot. This angle in here, this angle right here is beta. Okay. This angle in here is beta. So go ahead and find S and T, and then we'll be right back. All right, now that you're back, you know that in order to find S, I would use sine of beta equals to S over, is equal to S over 1, which is just S. So therefore, S equals to sine beta. S equals to sine beta. Does that make sense? Does S equals to sine beta make sense? Okay, so what I'm going to do is I'm going to take him back to here so that I can label him. And then I will write him like this. sine of beta, because it's going to get a little bit messy in this diagram, and I want to make sure that I don't lose anybody. Okay. So I'm also going to try to find that other pink side, and then you guys should know what that is. Okay, so if you didn't know what sine beta is, now you do. Now you can find t. I probably wouldn't be using sine at this point. What would I use? Very good. I probably use cosine. So I'm going to try to use different colors so you guys can all like see where that comes from. So then I go cosine beta equals to t over 1, which is just t. So there's my next one. Cosine beta equals to t. So I'm going to take him back over here and write cosine beta. Okay, and I wrote him kind of big because I want you to know that it's that whole pink length. Okay, so everybody good so far? Any questions for me right now? All right. So now that I know that, I can now move on to other right triangles. Now your brain should always go like this. Oh, let me move on to this right triangle. So if you look at this, there's a lot of right triangles that I can talk about, but there's only some of them that I'm actually going to find because I don't need everything. Because our whole goal is to find sine of alpha plus beta. If you know what sine of alpha plus beta is, it's actually this blue side. I'm going to be looking for this blue side. So anything that attaches itself to that blue side or a length that's equivalent to that blue side, that's what I'll be looking for. So the first thing that I'm going to notice is, oh, that blue side is the same as this. Wait, can you guys see what I'm highlighting here? Sorry, I don't know if you guys can see that. There. That side, that's the side I'll be looking for. Because of that, I'm actually going to look for this triangle here. Does everybody see that? That's the triangle I'm going to be looking at, the green, pink, blue. So that OAB triangle is the next triangle I'm going to go after. So I'm going to draw that over here. I'm going to go, let's see, green this way, blue this way. Hopefully this color coding is helping you understand what I'm doing. And then let me label it. This is alpha in here. This is O, A, B. I know that this side here is cosine beta from our other learning. And now I'm just going to look for the blue side and the green side. I'm going to be looking for the blue side and the green side. And actually, in reality, I probably don't even need the green side. But I might as well find it right now, because if I find it right now, then I might later on need it. Okay, so I am going to look for this side. Usually Miss Johnson, she will call the vertical side Y and the horizontal side X. So that's what I'm going to do. And so go ahead and use that. And I know it feels weird because look, Y, the hypotenuse is cosine beta. Just remember cosine beta is a number. Don't be intimidated by the fact that it's cosine beta. So try your best, find it, and then come back to me. All right, so next color, here we go. So I'm going to write sine of alpha equals to y over cosine, oops, let me use the same color, y over cosine beta, right? And if I'm solving for y, I would just multiply both sides by cosine beta. So then it actually looks like y is equal to cosine beta sine alpha. Confusing? Okay, maybe not, maybe a little bit. If you're feeling like, oh my gosh, I would never come up with this on my own, you're not supposed to get it on your own. That's why I'm here. Okay, so I'm going to write this out as, and I'm going to just write it in blue so I can keep track of my colors, cosine beta sine alpha. Do not switch those two angles. Don't be like, oh, I can do cosine alpha sine beta. No, because that's a completely different length. Okay, so I'm going to write that here along this side because that's what it is. Uh-oh, what is it? It is cosine beta sine alpha. So this is cosine beta sine alpha. I hope I got it right. Cosine beta sine alpha. I did. Okay. So I'll be making that bigger and bigger. Sorry, my iPad is on a bunch of papers. Every time I turn it, it's like making noise. Okay. All right. So that's done. So I'm also going to find this green side in case I need it later. So of course that's going to be cosine. So that's going to be, let's use this color, cosine of beta equals to x over cosine. Wait, I did this wrong. Sorry. Let's try this again. This is cosine of alpha. Cosine of alpha equals to x over cosine beta. And of course you would multiply by cosine beta on each side. So then you get cosine beta times cosine alpha equals x. Let me put this guy in a box because I forgot to put him in a box. So that guy goes right here. Cosine, what did I say? Beta cosine alpha. Cosine beta cosine alpha. That's that whole side. So if you're a little confused right now, you're like, what the heck, Miss Johnson? What are we doing? All we're doing is we're using the definition of sine over and over again. We happen to have funny looking hypotenuses, but that's okay. All right, again, my goal is to find that blue. The blue. That's all I'm trying to do is find the blue. So when I find this blue, all I need is this top part here. This is all I'm missing. And I'm going to call him, what, I haven't used W, right? Yeah, let's use W. I haven't found this W part, and that's all I'm missing. If I find that W part, then I found that whole blue height from R to S, which is the same as C to A, right? So I'm going to use that top triangle right there, which is RCB. So I'm going to draw that. I think it's blue on this side. It's pink on this side. And then it's nothing on that other side. So I'll just connect it this way. And this is a right angle. This is RCB. And the thing I don't know right now is I don't know any of the angles. And so I'm going to play around with my angles right now just to find, I want to find one of those angles. And so one of the things that I do know is I know this angle here is 90 minus alpha, right? Yeah, it's 90 minus alpha because of this right triangle, OBA. If I know that this angle here is alpha, then the other angle is going to just be 90 minus that, right? So that means that all three of these angles in here will have to add up to 180. So then if you use your adding skills right here, 180 minus 90 is going to be 90. So if this guy here is 90 minus alpha, that means this guy here has to be alpha. He has to be alpha. Because alpha plus 90 minus alpha is going to give you 90, which is it's the rest of that 180, right? If you don't believe me, plug in some numbers and you'll see that this angle here is congruent to this angle here every single time. Okay, so let me just continue. So this is going to be alpha. And so now I want you to find these two. Actually, I just want you to find W. But because we're finding W, we might as well find this other letter X. No, I've used X, X, W, V. Let's use V. So go ahead and do that. One thing I forgot to label was this is sine of beta. Okay. Yeah, very good. So now we're going to write, let's see. Okay, cosine. So cosine of alpha equals to W over sine of beta, which implies that W equals sine beta cosine alpha. I'll put a little box around that. So that's sine beta cosine alpha. So I'm going to erase this W and write. Undo that. Sorry. Let's see. Sine beta cosine alpha. All right. And because I also want to find the top there, I'm going to use another color. Do I have another color? I don't have another color. All right, we're going to go into rainbow colors. All right. So then we have sine of alpha equals to V over sine beta. This is a crayon color, so it's just going to be whatever color I want. So V equals to sine beta sine alpha. So is that, what am I doing here? Yeah, so this is going to be small. So this guy here is sine beta sine alpha. That little tiny guy right there. Okay, I think I found all of my pieces that I need. But anyways, I was looking for sine of alpha plus beta. So in this triangle, if I'm looking for sine of alpha plus beta, I am looking at yellow and then a little bit of green and then this blue guy, right? Which is OSR. This angle here is alpha plus beta, which you've never seen an angle be listed as alpha plus beta, but technically you have. If I've ever shown you a 30, 60, 90 triangle, which I have, right? I don't want that triangle to look like this triangle, sorry. If I've ever showed you a 45 higher, I'll do 45. If I've ever shown you a 45, 45, 90 triangle, technically I have shown you because 45 is really 20 plus 25. So it just looks funny because it says alpha plus beta, but don't think that I haven't shown you something like this. It just, the presentation of it looks different, right? It's like almost like you seeing $100 bill before. You've seen $100 before. You've seen 520s or 1010s or whatever, but seeing $100 bill is just a different presentation. Okay, so I'm actually looking for sine of alpha plus beta. I know that the hypotenuse is 1, and I'm looking for this guy right here, right? And so if you look, he is made up of these two right here, sine beta cosine alpha plus cosine beta sine alpha. And I'm going to write it how I like to see it because it makes my memory go faster. So I'm going to write this as those two over there. And I'm just going to switch people around a little bit. Okay. And the only reason why I'm switching people around is because it makes sense to me. Okay. So give me 1 second. Oh. Okay. So the way I like writing it is I like writing sine cosine plus cosine sine. So I'm going to write it exactly as I remember it. And so let me grab it in the two colors that I did it. So I'm going to write sine cosine. And then I'm going to put up a little plus sign. And then I'm going to put it in blue. Cosine sine. And the way it goes is alpha, beta, alpha, beta. So alpha, beta, alpha, beta. Okay. So then I'm going to write it over here. So the sine of this guy, because it's opposite over hypotenuse, and the hypotenuse is 1, it's literally going to be what you just saw. So it's going to be I'll just write it again. Sine, cosine, cosine, sine. And this is where I'll change colors. I'll go alpha goes first, and then beta goes second. So this is an identity. So what does that mean, Miss Johnson? This is an identity that I will use over and over again in order to prove your other identities for the rest of this lesson. Okay. So how did we get this, Miss Johnson? So if you didn't understand all of this, you don't have to. If you are like, what in the world did we just do? You don't have to come up with this. You just have to be able to be like, wait, I could use the sum identity. Okay. And the way you're going to do this is, and I'll show you really quick. Let me find one really quickly. Okay, here's a perfect one. They want you to find the sine of 75 degrees. All right, off the top of your head, do you know the sine of 75 degrees? Everyone's like, no. Good. So then you're like, but wait a second, Miss Johnson, I could use sine of alpha plus beta. And I'm like, oh, okay. Well, what would you add together? And so then you're calling on your 30, 60, 90 friend and your 45, 45, 90, right? And so now I want you to think about this. How could I rewrite 75 so it's made up from 30, 60, 90, 45, or 45, and or 45? So let me write that down. So here are your Lego pieces, 60, 90, 45. I say, here's all your Lego pieces. I want you to build me a 75. And you're like, build a 75? I'm like, yeah, build me a 75. So what would you put together? What would you add together to make you a 75? Okay. Someone says 60 and 15. Absolutely. But 15 is not one of my Lego pieces. I'm only allowed to use these right here. The reason why I'm only allowed to use those is because I know those, right? I don't know about angle 15. I don't have a special right triangle called 15. So try again. What two numbers can I add together that makes me a 75 degrees? Yeah, I could do 30 plus 45. Okay, so I'm going to write 30 plus 45. So this angle that was obscure before, sine of 75 degrees, is now no longer obscure because we can use that formula. So I'm going to do it with you. Sine, cosine, cosine, sine. Oops, I ran in. Miss Johnson, she writes too big. Sorry, guys. So then I'm just going to put in 30 and 45. Okay, so 30, 45, 30, and 45. And you're like, Miss Johnson, this is better? Yeah, this is way better. Because if you put this in on your calculator, it gives you a decimal answer, and they are asking for exact values. See this? Exact values. So the sine of 30, I'm going to just draw really quickly my 30, 60, 90 in case you don't know, and my 45, 45, 90. Sorry, these are really bad pictures, but that's okay. So this is 1, 2, root 3. This is 45. This is 1, 1, root 2. Okay, so sine of 30 is opposite over hypotenuse, so this is 1/2, times cosine of 45 is 1 over root 2, plus cosine of 30 is root 3 over 2, sine of 45 is 1 over root 2. And then I just write. Okay, so this is 1. Wait, why did I put root? Sorry, I wrote this wrong. This has to be root 3, Miss Johnson. So this is 1 over 2 root 2 plus root 3 over 2 root 2, which is just 1 plus root 3 over 2 root 2. Miss Johnson, that's an ugly answer. Yeah, but let me show you. When I go to Desmos and I say, hey, Desmos, can you give me sine of 75? they give you, wait, is this? Yes, it's in degrees. Okay. They give you this number. And whenever someone asks you for exact values, I can't give you exactly sine of 75 for my calculator because I'd have to write all those numbers plus all the numbers that the calculator is not showing you, which apparently I can't write because I don't know them. So I'm just going to prove to you that this is correct by plugging this in. So 1 plus root 3 divided by 2 root 2. Do you see how they're exactly the same of the digits that they showed me? That means that I'm right. Okay, so let's go over this really quick. So, Miss Johnson, we did all of this proving so that I can use this formula. Yes. So your job is not to prove this like this. Your job is to be able to use this. When you see a problem like, where'd it go? I don't know. Here it is. Sorry. Like this. So if you want to try to practice this again, I would do this one. Sine of 255. Okay, let me tell you your tools though. Your tools really aren't just 30, 60, 90, 45. You also have access to these bars here, right? So you also have access to 180, 270, 360. So when you're building a 255, you're like, wait a second, I could use 180. Yeah. So then subtract 180 from there. If I subtract 180 from 255, I get 75. Wait, can you use 15? Oh, can I do 15 or 16? Oh, okay, very good. So yeah, you're just gonna build this accordingly. Okay. So one of the ways to build this accordingly is if you graph 255, he's like right here. Right? So you can also subtract 90 off of there. What's 90? What is that? 165, which I don't necessarily like. So yeah, sine of 255 would be 180 plus 75, which now we know sine of 75 is right there, right? So there's other ways to do it. Just because I came up with one doesn't mean that you have to do that. Technically, you cannot, of what I showed you, you cannot do 15 and 16 yet. So you're going to have to go to the other video to see, because in the other video, I will show you what sine of alpha minus beta look like, cosine of alpha plus beta, and cosine of alpha minus beta. And then these ones too. So I just go on to the next video and then you'll see. Okay. All right. Thanks for listening. Oh, by the way, again, the hardest part for this part right here is going to be this part right here, where you came up with 30 plus 45. Because the rest of that is just you using the formula. So then I literally transported you back to integrated 2, because that's where you learn sine, cosine, and tangent of your 30, 60, 90, and 45, 45, 90. So again, the hardest part is going to be you breaking 75 up into pieces that you can use. Okay. And then, by the way, this sine of 255 could also be written as a alpha minus beta too. Okay, so go watch the second video and then it'll make more sense. Thanks for listening.